when you think about an operation, you can represent this operation by means of a table. So for example, if I have a value A is true, so this is a variable, I've set its value to true, and B is false, then we can create, so I'm going to print out the result of applying the AND operation to A and B, right? So if A is true and B is false, then A and B will be false, right? So AND will be true only if A is true and B is true. So there are basically, how many combinations can there be for A and B? If A can take 2 values and B can take 2 values, there are totally 4 values, right? 4 possible choices. A can be true or false, B can be true or false. So I'm going to pause for a couple of seconds, and I'm going to ask all of you, can you make all the 4 combinations for A and B for the AND operation? I will pause for a minute, so you're not just watching me type. Can you change? So maybe you have to change the values of A and B. I'll do one more. And for example, I can change B to be true and then print it out again. So can you do the other 2 and just chat me when you're finished?
No, John, I was asking, like, can they just print, like, instead of A equal to true and B equal to false, they can just type 4 conditions as true and true and true and false?
Of course, you can do that too. So for example, I think what Manish is saying is you can just, instead of using a variable, you can just type this way too.
I think, like, on chat, it will be easier for them to get that.
Yeah, you can do this way too, right? You can just, instead of using a variable, you can type the values into it. Okay, so the idea is the following, that because this function has only 4 possible inputs, the entire behavior of the AND operator can be captured by these 4 possible inputs and outputs. So the 4 possible inputs and the 4 possible outputs can be put into a table, right? And that table is called a truth table, right? So now I'm going to make a statement, which is a very profound statement. The statement is, any function technically can be thought of as a table that relates a set of inputs to an output column. So think about that one more time. Any function can be thought of as a table that relates a set of inputs to the corresponding outputs, right? The reason why this thought process is not powerful enough is that in general, the set of inputs may be infinite. And so the table will be infinite. And so you cannot enumerate all possibilities. But when we have Boolean inputs, it is possible to completely enumerate the table, right? You can specify all entries in the table. And so it's a beautiful thing that functions in the Boolean world, at least with small number of inputs, can be fully specified by tables. So there's a beautiful way to think about functions as tables. Now, we do use functions as tables in mathematics. We use them when we want to generate graphs. But in that case, we take a few set of points, a small number of inputs, and we use that to kind of graph the function, right? So again, a very deep mathematical concept, but here very practical. Whenever we see an operation, a Boolean operation, we can ask the question, what is the corresponding table?